So today we introduced the idea of solving systems of equations using this technique we're calling elimination. And I just want to go over the first example we looked at in class today. So just kind of have a chance to look at this and consider it a second time. So for this system, right, our thinking is this. It is certainly allowed that if I have equal things, right, I can add equal things to both sides and still get equal things. So what did I just say? I don't know. Let's think about this. If I consider this equation right here first, that equation, um, I can certainly start with that equation. And if I add 16, right, if I add the number 16 to both sides, I'm going to get an equivalent equation. What do I mean by equivalent equation? Let's look at this. So that's 2x plus 3y is negative 2. So in Desmos, I can write 2x plus 3y equals negative 2. So you can see this is an equation, and every single xy point on this line is a solution to this equation. So for example, you can see here's a nice one at negative 4, 2 is a solution. You can see here's my x-intercept, here's my y-intercept. But again, all these points are solutions. I could stop right here, and it looks like when x is 2, y is negative 2. So it is certainly true that if I take the left-hand side, right, 2x plus 3y, and I add to both of the sides the number 16, on the other side I'm going to take negative 2, negative 2, nope, negative 2, hello, negative 2, plus 16. When I add 16 to both sides, you can see I get this new equation, but it's exactly the same equation, right? This new equation's in purple, the original one's in green. And the purple equation and the green equation have all the same solutions, right? That's what I mean by if you have equal things and you add equal things, you get equal things, right? So this equation, if I start with it and I add 16 to both sides, I get a new equation that's equivalent. If I come back to what we're looking at in our problem today, this problem, I can say, hey, consider this side. This side has 2x plus 3y equals negative 2. If I add 16 to this side, I know that this side is going to become positive 14. Now, instead of adding 16 to the other side, right, I'm going to take this a step further. I can add something that is equivalent to 16. So instead of adding 16, right, I can add this thing, which is equal to 16. How do I know they're equal to 16? Well, this system tells me they're equal, right? 16 is the same as 5x's and then subtract 3y's. So if I come in here and I do that, I'm going to add to the left-hand side 5x's, and then I'm going to add a negative 3y. What do I get? Well, 2x's plus 5x's is going to give me 7x's. And if I take 3y and I add negative 3y, that gives me 0. The fact that that just happened is why we call this elimination, right? My y's just eliminated because I had a positive 3y and a negative 3y. So I land at this new equation, which means if I divide both sides by 7, x is 2. And now I can use this value of x in either one of the equations to figure out what y is. So that's what we're looking for. We're looking for equations where we have either our x's or our y's are all lined up so that when I combine or I add the same thing to both sides, one of my variables eliminates. Or, something plus its opposite is 0, so it eliminates. So that was one place where that happened. And then there were some more, right? So other things that we looked at today. We had this problem. Oh, it's not very clear. It should clear up. It may not clear up. But on this problem, essentially what I'm doing is I've got this 2x minus y equals negative 2. And on both sides of this, I'm going to be adding 10 or something that is equal to 10, right? So on the one side, I add 10, right? And I get this, if I add 10 to this side, I get this new value of 8 over here. And on this side, if I add something that's equivalent to 10, which is namely negative 2x and then plus 3y, right? because this is the same as 10. Look what I did. I had equal things, and I added things that were equal to both sides, so I'm going to get equal things. On this side, I get 8. And on this side, I have the 2x and the negative 2x are gone, and this is just going to become a 2y. Therefore, y is the number 4. And again, just like the previous problem, I can now take this value of y and plug it into either one of the other two equations, and I could get the value of x. So that's the technique. It's called the elimination method. And we're going to be practicing this over the next couple of days.